Hello, this is Kate. Another day, another video. This could be the most requested video that I've ever got. You want the solution to the specimen's paper. I'm gonna do a solution of the specimen's paper. Start this series from AASL. I think this is maybe a popular choice. AASL. So we start with paper 1. I don't know how long this will take me to explain everything. So we'll see how many parts this thing gonna be. We're gonna start with section A. For AA, paper 1, it is true that you should not get a calculator for AA paper 1. Okay, so no calculator. No calculator. Okay, first one, very typical. Well, obviously the first question is supposed to be easy. If they give you cosine A, find sine A. So it's not hard, you just need to know what to do. What you do is you go to the formula booklet and find, under trigonometry, the Pythagorean identity. Okay, so cosine theta plus sine theta is 1. So obviously theta could be A. There's nothing to stop theta from being A. We know cosine A is 5 over 6, so this is 5 over 6 squared plus sine squared equal to 1. So obviously we just move this to the right, minus it, right? 5 over 6 squared. Now I don't want the video to be too long, so I'm gonna go slightly fast. So pause and rewind the video if you need to. What's that, 11? So that's just take a common denominator and subtract, and then you take square root. So it's plus minus, root 11, you can't do that, and root 36 is 6. Now obviously A is inside a triangle. If an angle is inside a triangle, is less than 180. When an angle is less than 180, when you sign it, it's always positive, so we're going to ignore the negative choice for this time. B for the area, so that should be easy. You go to, again, the formula booklet, find the formula for area. It should say half AB sine C. The only rule is AB are two sides, and C is the angle included by that two sides. Okay, so we're gonna take this to be A, this to be B, and the angle included will be this one, which is C, which is actually the A that we just found. All right. Very typical question. What is it again? 6 and 8. So sine C, remember sine the angle is this, okay? So it's that. The 6 cancel out, the 2 and 8 cancel to be 4, so it's 4 root 11. Okay. Second question about probability. Okay, so it looks to be some sort of a Venn diagram setup. So it'll be a bit easier, this question, if you know you should do a Venn diagram. A, B. So they say the probability of A is 0.5, so A is 0.5, B is 0.4. Okay, so common mistakes, you cannot put 0.5 here, because if you put 0.5 there, it would mean that this area is 0.5. But what the question mean by 0.5 is that the whole A together is 0.5, which means this bit plus the middle bit together is 0.5. So don't do that. So the key is, what is the intersection in the middle? So common way to do it is let the middle be x, then the outside here is 0.5 minus x. The right hand side, similarly, 0.4 minus x. We know the union of A plus B is 0.6. So that means if we add up all three of these, you should get 0.6 because that's the union, right? So 0.5 minus x plus 0.4 minus x together give you 0.6. So minus x plus x cancel out, so it's 0.9 minus x 0.6. That means x must be 0.3. Okay, so we can update our information. So the middle here is 0.3. A together is 0.5, so the left bit must be 0.2. B together is 0.4, so the right bit must be 0.1. They are looking for probability of A intersect B. So this is a conditional probability. It means the probability of A given B. If you go to the formal booklet under statistics and probability, conditional probability, you would found the formula is A intersect B over probability of B. Nice and easy. A intersect B is here, 0.3 over probability of B. This is another place where people do mistakes. B is the whole B, okay? So don't put 0.1 under. It's the whole B, which is 0.4. 0.3 over 0.4, obviously 3 over 4. Done. Question 3. This one is a new type of question in AASL. It's kind of like a proof technique, but it's not too hard. These are called direct proof, so just do it directly. So part A, to show that, you simply expand the left-hand side, and that's all you do. Okay, so it should be pretty direct. So we just square it. Remember, this is 2n minus 1 times 2n minus 1. Similar for the other one. Don't do a squared plus b squared. Okay, don't turn yourself into a meme, if you know what I mean. So just expand. Did I do it too fast? So it's plus 2n plus 2n plus 1. So this is 4n, similar to that one. Plus. So minus 4n and plus 4n would cancel out. 4n squared plus 4n squared is 8n squared plus 1 is plus 2. So that's it. Get the right hand side. So hence prove that the sum of the square of two consecutive odd integers is even. Now I'm guessing in the actual exam it is even possible to just give you this part and give you 5 marks. Okay? Part A is basically how you do part B. It's like direct, very direct. The sum of the square of two consecutive odd. If you think about it, this is exactly what it says on the left hand side here. 2n minus 1 is an odd number. 2n plus 1 is the next odd number. You square them and you add them up. So that's already exactly the sum of the square of two consecutive odd integer. Okay? Now, in case you're still thinking why is 2n minus 1 odd, the reason is if you have any integer n, where n is an integer, z means integer, if you multiply by 2, so 2n, that's even. That's the meaning of even number, right? So this is even. Therefore, if you do 2n minus 1, that's odd. Because if you have an even number, you take 1 away, that's obviously odd. If you already have an odd number, what's the next odd number? Well, the answer is you add 2 to it, right? That would give you the next odd number. So the next odd number is 2n minus 1 plus 2. But minus 1 plus 2 is 2n plus 1, okay? So this is exactly two consecutive odd number. And you square it and you add them up, okay? So we know that, so from A, we know the sum would be 8n squared plus 2. Well, all we need to show is that this sum here is even. Well, again, even means it is 2 times some integer. So we obviously just factor 2 out. Then we have 4n squared plus 1. If n is an integer, then n squared is still an integer. If n squared is an integer, 4 times n squared is still an integer. Integer times 4 is an integer. And then you add 1, that's still an integer. So this is an integer. Okay? So this is even. this is even, as 4n squared plus 1 is an integer. Okay, so this is so-called direct proof. Probably new type of question. I don't think this ever come out in the old syllabus. So pay a little bit of attention to this. Do some practice on this. Next. So they give you the derivative. F prime x is the derivative. You want to find the original function. Okay, this is obviously integration. So you need to integrate this. If you have studied integration, if you have learned substitution, it should also be obvious that you need to do substitution. Okay, and it should even be obvious that you would make the denominator be a u without the square root though. It's easier if you do it without the square root. So normal procedure of doing substitution, you differentiate both sides with respect to x. So differentiate this. You make the x the subject, so by that you would multiply the x to the right. It's not technically a multiplication, but close enough. Then dx is d over 4x. You substitute it in. Therefore, the integral of 8x over square root 2x squared plus 1 equal to the integral of 8x over square root of u du over 4x. In case you don't know why we do it, it's obviously because x would cancel out. 8 and 4 cancel to be a 2, so it's 2 integrate 1 over root u, that is u to the power of negative half. Now if you have a huge trouble of doing this, well, I have a course for you. I have a full course on AASL calculus, so including everything you need to know for differentiation and integration in Udemy. The link is down below. If you you grab it fast enough, there should still be a link where you can get it for free. There are also discounts from time to time, so you can check it out. See if you would like to get my whole course on this, where I would break down, I would teach you how to do substitution in extreme details. But for now, that's what you do. So just integrate that, so you add 1 plus c. So this should be 4. When you put the u back, u was this. So it's 4, 2x squared plus 1, the power of half, plus c. Okay? And this is fx, because you have integrated the thing. Now for this type of question, you need to find c. Most likely when you do indefinite integral, you don't need to find c, but for this one you do. You do with this information. F0 is 5, so when x is 0, the functional value is 5. So 0 squared is 0, 0 times 2 is 0, 0 plus 1 is 1, 1 to any power is still 1, 1 times 4 is 4. C is 1. So I hope I didn't go too fast. But I do want to keep this one short. Okay, if you get my course, I would go through everything quite slower there. Yeah, that's the solution. Okay, moving on to question 5. So part A, show that this thing equal to 2x plus 11. So you just need to know this means composite function. So g circle f really means g of f of x. And that means putting f into g. So this is f. And by putting it into g, I mean you substitute this to the x of g. So it's 8, that whole thing, plus 5. So the 8 and 4 cancel out, to be a 2. And then you expand the 2 in. So it's 2x plus 6. And you add up to that, which is what they want. So this is the meaning of show. It's only there for you to check your answer. You're not supposed to use this to do part A. But it is there for the purpose that if you don't know how to do part A, you can use this answer to move on and do part B. Okay? But you're not supposed to use that while doing part A. So part B is about the inverse of GA circle F. So you need to find the inverse of this function. So you make it equal to y. And you make x the subject. So you take away the 11 and then divide the 2. So some of you may learn it to interchange xy from the beginning. You totally can do that. Make no difference. Here I do it at the end. Again, it makes no difference. So this is the inverse. So the question says if you put a in, you should get 4. So you put a into x, you're supposed to get 4. So find a. So just solve for a, right? So a minus 11 would be 8. You multiply the 2 to the other side, and then you get 19. Done. Next. So again, this is a show question on log. So part A. So when you show, you start from the left-hand side. Okay, what should we do? Now the key is in the answer that they want you to show, the log have a different base. So it should be obvious that you should use the change base formula, which is in the formula booklet. So let me find it. I want to use the exact form that the formula booklet give it to you, so you can understand better. So this is the change base formula. Okay. So it should be obvious that this a is the 9. That's the 9 here, and the x is this whole thing. Okay, so according to change base formula, it is log x, which is the whole thing, over log a, which is the 9, while the b's, the 2b are the new base, and that is up to us. So we can choose the new base as long as they are the same. But this time, obviously, we'll make it 3 because the question wanted it to be 3. Okay, then the top, there's not much we can do on the top. Then the bottom, the key is we know the value of log 9 base 3. What's log 9 base 3? Well, it's 2, right? Okay, in case you don't know, that's because log really means the base to the power of what would give you 9. The question is 3 to the power of what is 9? And the answer is 2. That's why log 9 base 2 is 2. Okay, in case you want a full course on this, you should check out my Udemy course, link in the description. So when you divide by 2, that's the same as saying you multiply the whole thing by half. When you multiply the log by a number, you can move it to the power inside the log. So that's one of the properties that is inside the booklet. And a power of half is obviously a square root, which is exactly what the question wants. So we got it. Okay, so that's part A. Part B, hence or otherwise, solve this. We'll obviously do hence, so we'll use part A. And it should be obvious that this is where you can use part A. So you can just replace it by what we just got. So log base 3 to sin x equal to what we got, log base 3 square root cosine 2x plus 2. So the reason why that's a good idea is now that the two log have the same base. Whenever that happened, you can, whenever you have two logs of the same base equal to each other with nothing in front, so nothing in the front here, you can just cancel the log pretty much. So we get this. Okay, this is where we square both sides to get rid of the square root. Remember to square the 2 as well. So it's 4 sine square cosine 2x plus 2. So now you go from a log question to a trigonometric equation kind of question. So it should be obvious that you use the cosine double angle formula here. If you go to the formula booklet, there is 3 forms. There are 3 formulas for cosine double angle. You need to learn to choose which one to use. In this case, due to the left-hand side having a sine square, we'll use the one that has a sine square. So according to the formula, it should be 1 minus 2 sine square x plus 2. Okay, so we move this to the left, become plus 2. So 4 plus 2 is 6. 1 plus 2 is 3. And then we divide the 6. 3 plus 6, 1 over 2. Take square roots. So, when you root a fraction, you root the top and the bottom. Root 1 is 1, and root 2 is root 2. Of course, also, when you take square root, there's plus minus. Just minus for this side. I already did the plus sign for the other side. Okay, 1 over root 2 is a special angle. So you should memorize it, that x is 45 degrees. That's of course only the first answer. If you do, there are a lot of different ways of doing the unit circle, or we call this cast diagram. There's different ways. Use your own way. The end answer for the positive side should be in S. So that should be 180 minus that. So that's what, 135? For the negative side, we go to T and C in order for sign to be negative. Right? That's one of the way of finding the other answers. So it's 180 plus 45, 225. Or 360 minus 45, 315. Alright. Okay. So you should really be familiar with this, how you find the other answers. If you look at the question, only want x to be between 0 to 90. Pi is 180 radian. 180 divided by 2 is 90. So it's really only this one, which in radian, that's pi over 4. Okay. Not too hard. It's not too hard. Oh, this is the last question of section A. Oh, it's easier than I thought. It's easier than I thought.